we are going to use the chain rule to find the derivative. We have h of x is equal f of g of x. So that. So when we take derivative, I just write the function again, f of g of x. Just going to use different color for g of x. Then when we take derivative, it is going to be the derivative of the parentheses and then the parentheses derivative of the parentheses. Doesn't matter if we have g of x or whatever it is inside the function f. Now we have g of x. So we check derivatives, and we should have f prime of g of x and then g prime of x. Now we're just going to substitute 4 into x, and we have derivative of h at x equal to 4 equal to derivative of f at g of 4 and g prime at 4. And then we just look up for the values in the table. G of 4, the function g at 4 is 3. So we have 3. The derivative at 4 is 2/5. And then we have the function f prime, and derivative of f at 3, derivative f at 3 is -3. So we have -3 here. Bottom line, we will have -3 times 2/5. -3 times 2/5 is -6/5. Right. So that's the first part of the problem. Second, we have p prime at 1. The function p of x is g of f of x. Right. Now we check derivative. It is going to be derivative of the outside function and then derivative of whatever inside of it. So we have g prime f of x, f prime of x. Now we check derivative when x equal to 1. So that will be g prime at f of 1 and f prime of 1. Right, now we look up the values in the table. F prime of 1 is -8. F prime of, f of 1 is 4. And we still have derivative of g of at 4. Right. Derivative of g at 4, derivative g at 4, that will be also 2/5. Right. And then so we have 2/5 times -8 So that is negative 16 over 5. So when we are not given a function, we have to look up the values in the table. And that's what we do.